Hello and welcome to our second day working with trigonometric equations, specifically the cosine, and we're working on solving cosine equations or trigonometric equations with horizontal and vertical transformations. Today we're going to avoid trig exact values and we're going to have to use a calculator, and we're also going to work in radians. So you want to make sure you check the mode on your calculator when calculating for radians. Keep in mind that our goal here is to transition away from the unit circle. It's a great way to memorize values, but we're going to want to look at a sinusoid, the graph of a cosine or sine or tangent, and we're going to want to see how those graphs work similar to other families of functions we've worked with. So we're transitioning, understanding quite a bit from the unit circle, looking at the graph of a sinusoid. So here's a good example of a sinusoid here. If we were asked to find theta, the values between negative 360 and positive 360, for a given equation here, it's a fairly basic cosine theta equals 3/7. We would look at this graph and have a sense of it. We're going to have to use a calculator since we don't have the trig exact value of 3/7. I don't know what that is. My brain doesn't work like that. We're also going to find our answer in general, which, thanks to symmetry, cosine's fairly easy. So to get started here, we have the cosine of theta. We need to undo cosine. The way you undo cosine, either arccos or inverse cos. I'm going to use them interchangeably. The inverse cos of cos cancels out cosine. We get theta equals the inverse cosine of 3/7. Now, if this was square root of 3/2 or square root of 2/2, I'd be comfortable knowing that angle. Unfortunately, I don't. So using the graphing calculator, I do the inverse cos of this ratio. I get 64.623 and change. If I look at my graph here, that's this spot right here, 64.623. Okay, and then also negative 64.623 is here. And the reason I like having that, we notice the symmetry again. The reason I like having that, if you were to look at this curve, it's a complete cycle by the time it gets to here. Well, how am I going to find that value? It's not got an obvious connection to this value of 64. The way I do that is I take one complete period, add it to my negative 64, so that's 360. I get 295.37. So if I wanted to find all values from negative 360 to positive 360, I have 64, negative 64, and change. And then I also have the negative 64 with one period added, 295, and then if I subtracted 360 or just put a plus or minus in front of the 295, because cosine has some symmetry, the other trig functions won't, I can get an answer like plus and minus 64.23 degrees and plus and minus 295.377 degrees. In general, we simply put plus or minus the 64.23 degrees and then add one period, remembering n is an integer, can be positive or negative. Okay. Our general solution again then has the inverse cos of our ratio, in this case not exact values, we're going to need to use a calculator, and we're going to really be using radians as well. So here we go. Once you give this one a try, find theta in general, and then for this interval negative 360 to 360. So I've switched the order a little bit. Go ahead and try this one. Okay. Probably not going to show this algebraic step. Don't know that you really need to because I'm pretty sure you understand it. But theta equals the inverse cos of 4/7, the angle whose value produces a 4/7 when you take the cosine. And our graph here, 4/7 is going to be somewhere slightly above half here. But we really don't need this visual. All we need is the calculator values of inverse cos 4/7, 55.15 degrees, and negative. So again, just to get us familiar, the 55.15 shows up here. The negative shows up here. And we can add or subtract a period to get every subsequent value. And hopefully when you did the math, you found that theta equals plus and minus 55.15 plus and minus one period. And now when I want to find just the values from negative 360 to 360, the way I'm going to write it is theta equals plus and minus 55.150 degrees, and this value of 304 plus or minus. And again, this is because of the symmetry, and we don't have a phase shift. The phase shift will steal some of the nice symmetry we could have in a cosine. So here's my two answers. Hopefully that's what you got. I want to point out that using units for degrees is critical. You will lose points if you don't label with degrees. It's assumed to be radians if you don't include units. And today that starts to matter. Okay, let's look at a problem now where we already have the equation solved for x. So in some ways this is easier than the previous one. It's just terminology you're probably not familiar with. So really the step before this would have cosine of x equals 0.7. We are cosine both sides. We're looking for all solutions here, all angles whose cosine equals 0.7. All right, when we look at our graph here, we want the elements, we want the general, and we want the values between negative 2 pi and positive 2 pi. We've got that labeled. You might want to start getting familiar with what pi and 2 pi equals as a decimal, because values when we calculate are going to be kind of weird looking. So we plug it in the calculator. The inverse cos is 0.795 roughly radians. So we could say our answer then for A is x equals plus and minus 0.795. We're going to use generally 3 decimal places plus 2 pi n. 2 pi n. All right. That gives us our answer. N again is positive or negative. And now we can find our values on the interval from negative 2 pi to 2 pi. X equals plus and minus 0.795. And then on the calculator I did a little bit of work here. I took the negative and added a complete cycle. So I started here, added a complete cycle to get the next value that repeats from there. Similarly, I could have taken the positive value that I got and subtracted 2 pi. But anyway, and plus and minus 5.488 radians. Now, since I didn't put units, it's assumed that I have radians here. Okay, why don't you try this one? This is a similar problem. We have the general solution in radians, and again, make sure you're in the right mode. And then our interval here is actually from 0 to 4 pi. We don't have any negative values. It looks like we should have 2 complete cycles since this angle or this cosine curve has not been transformed really at all. Another thing to just mention here, this is as if we've taken our first step. The cosine of x equals negative 0.3. We've already undone cosine with arccos. This gives us all angles whose cosine equals negative 0.3. So we're going to find the general solution in radians and then along the given interval. And you will need your calculator for this. All right, so to answer the first one, goes pretty quickly. We simply plug into our graphing calculator. All right, so to find our first answer, we're going to have x equals plus or minus the first value here, 1.875, and that's in radians, not a real familiar looking number to me. Another thing to notice is that this value, 1.875, your calculator has something called the principal branch programmed in. It knows how to find a certain value or a range of values that we then can use addition and subtraction of periods to find all possible values. So we'll be using the principal branch calculator gives us to get all answers. And then we add 2 pi n. This will give us all values. Now for the second part here, I've already got the values in there, but I want to point out it'd be nice if we could avoid looking at the graph in the long run. We can just use a calculator, but for now it helps to see where these values show up. So our first value we said 1.875. By symmetry, we can say this value is negative 1.875. If I were to add 1 period, I would get to this corresponding value, 1 period up. If I added 1 more period, I would get another value. It'll be over here. Likewise, this spot here, if I add 1 period, as a duplicate answer here. And again, looking at our answer, we wanted 0 to 4 pi. So this negative value, negative 1.875, is not part of the answer for B. So I did need to add 2 periods to get to there. If we look here, 1.875, added a period of 2 pi. Then I took the negative value and added 2 pi right away. And these are all our values then. X equals 1.875 and 8.159. And then a lot of times I write this as a kind of a string here. I would say X equals, instead of just putting a comma, 4.408. And that's this value here, the one that took the negative radians and added 2 pi, which is roughly 6. And then another 2 pi added to that gives us 10.691. And then if we go any further, we get values that are larger than 12.57 if you start adding 6 and change to any of these larger values. So there's our answer for on the given interval. Okay, here's where we get to the tough problems. Watch, follow along. We undo the outside transformations first, then we undo cosine, then we undo the inside transformations. So to start with, we're going to subtract 5 from both sides, giving us 2 cos 3, x minus pi over 9 equals negative 1. Now we undo the times by 2 with a division. Now we're going to get negative 1/2 here, which is a trig exact value. We can do this without a graphing calculator. You can use a graphing calculator when allowed, but you should practice your trig exact values. We're going to undo our cosine with arccos. When we do that, it's going to be useful to see that we have 3, so our cosines cancel out, our cosine cancels out, we get just the argument, equals these values. So what negative 1/2 is over here in the quadrants 2 and 3, 2 pi over 3 or negative 2 pi over 3 would give us those values. Now I divide by 3 as my next step, and I can leave the plus and minus there. I'll get 2 times 1 over 3 times 3, so that's 2/9 pi. And then I also get negative 2/9 pi. Here, now that I have a phase shift, I need to split this up because I'm going to undo the minus pi over 9, and when I add pi over 9 to 2 pi over 9, I get 3 pi over 9. You're going to be tempted, as mentioned in the previous video, to put plus or minus 3 pi over 9. That won't be correct because 3 pi over 9 is different than negative pi over 9. Likewise, we don't add the phase shift to the period. The period's been transformed by a stretch or shrink. We don't add values to make that larger or smaller. So now we've got x equals 3 pi over 9 can be reduced, and negative pi over 9 with a period. That's our complete answer, the general solution, and we're done. Now, it's worth checking just because these values look kind of strange to me. So I went ahead and ran a random number, 7. I just plugged in 7. I get pi over 3 plus 2 pi over 3 times 7. That turned into 14 pi over 3. 1 over 3 plus 14 over 3 is 15 pi over 3. I plugged that in for x. My original equation was 5 plus 2 cos 3. I plugged in 15 pi over 3 for x, and I got 4. So I'm feeling pretty good. It's unlikely I can randomly just guess 15 pi over 3 and get the correct answer. So there's our answer. All right, why don't you try this one? Do the best you can. Make sure you're recognizing each of the steps here. There's quite a few steps. They're not as intuitive as Algebra 2 probably. As a reminder, you're going to undo the outside, undo cos, and then undo the inside. Go ahead and hit pause. All right, so the first 2 steps go pretty smoothly. 2 minus 1 is 1. I now undo times 5 with divide by 5. That gets rid of the 5 on the left side. I have cos 4 parentheses x minus 1 equals a fifth. That's not a trig exact value, so when I arc cos, I need my graphing calculator. I get the value in radians. Remember, we used x here, 1.369, and I still have some more things, some more steps to take because of the x not being by itself. I undo multiplication with division divide everything by 4, including the period. That's going to give us a dilation there. And now I just have x minus 1. Pretty easy to undo a minus 1 with a plus 1, only adding that to my radian values of positive 3.42 and negative 3.42. I'm going to remind you again, don't add 1 to 3.42 and put plus and minus. You're going to get two different answers. You have to separate the plus and the minus. That was just a shorthand for the notation. So we get these two answers. Hopefully that's what you got. Hopefully you also feel like you're able to get started and get through the material. Come into class with good questions. Here's the on your owns, and we'll start from there.